Uh, Welcome. Thank you all so much for joining this virtual faculty office hours for computer science. My name is Grant Sewell. I use he, him pronouns, Associate Dean in the Office of Admission, and we're very appreciative of you spending a little bit of time with us. We're also very appreciative that we're joined by two of our wonderful faculty members and one of our current students who is in the computer science space, Will. And I'll turn it over to them in just a second for more of an introduction and to get us started. But I know as we might be going, there might be questions that you're curious to know about, things that you want to unpack a little bit more. And if that is the case, I would encourage you to use the Zoom chat feature. That's going to be a good way to ask the questions that you have. And between the folks who are in the room, a good way for them to kind of speak to things you're curious to know about. So as we're going, feel free to put the questions in there and we'll do our best to kind of speak to as many of those as we can with the time that we have. With all that in mind, I might turn it over to our two faculty members and our current student to get us started, but maybe I'll turn it over to Adam first to start the introduction.
Yeah, so I guess let's start with some introductions. I am Adam Groce. I am a faculty member here. I'm currently the chair of the computer science department, though all that means is that it's sort of my turn this year. Um, I study cryptography. So you've sort of probably heard of that as like secret codes, right? Modern cryptography means more generally sort of how do you get computers to do the things you want them to do when some people wish they were instead doing something else. Um, so I teach classes on that. I study that. My particular specialty is in private data analysis, how you analyze data while protecting the privacy of the people whose data it is. So yeah, I've been at Reed, I guess, about 9 years now. Um, and I've been here as the program has grown. When I got here, there was no computer science major, and now we are one of the larger majors on campus. Um, so yeah, I guess I'll pass it off to Greg.
Yeah, sure. I'm Greg. I have been at Reed for fewer years, for 2 years. Um, and I work in machine learning, as well as program verification. Basically, you have a program, you have some idea of what it's supposed to do. You want to make sure that it actually does that. Um, so I teach in both of those areas, in program verification and in machine learning and deep learning. My particular research focuses on uh, how you kind of apply those verification ideas to machine learning systems. So you've got a system, does some kind of machine learning. You want to make sure it actually works. Uh, this turns out to be a hard problem. Um, and that's mostly what I study. What did I say? Yeah, so I've been here for 2 years, so not as long as Adam. I've been part of this department growing from not existing to now having quite a few majors per year. Yeah, and maybe we'll also let Will introduce himself.
Hi, my name's Will. My pronouns are he, him. I am a junior and I'm a math computer science interdisciplinary major, which is not quite a double major, but it's sort of a computer science major with more of a focus in mathematics. Um, and I'm part of the reason why they needed to hire Greg. Um, I came to Reed as a prospective computer science major, and I fell in love with the math curriculum and the like theoretical components of computer science. And I've really been enjoying. I'm taking some high level classes with Adam this year, and I really enjoyed them.
Okay. So I guess the plan is that I'm going to talk a bit about computer science at Reed and sort of how our program works. But this is really meant to just be kind of a basic introduction that should hopefully prompt some questions. So I will try not to take too long and hope hopefully you all have questions to ask us about the program. But I guess I should start with sort of like what our philosophy is of a computer science education. Because I mean, computer science is reasonably standardized, but I think sort of exactly what people mean by it can be a little bit different in different places. And what I like to say is that we do computer science with the emphasis on the science, right? If you just kind of saw computers and you wanted to understand them, the same way that a biologist wants to understand life or a physicist wants to understand the natural world, right? What kinds of questions would you ask? What would you want to find out, right? You learn how to program, you learn how to do all sort of like the normal things that you would expect to learn in a computer science class, but we are not sort of motivated by saying like, okay, we want to develop this piece of software, right? Oh, cool, there's this package, you import this thing, and then you call that function, and then look, some really magical stuff happens, right? If you get really good at that, you can make really cool stuff very quickly. But our goal is to teach you how that thing works, right? To make you the sort of person who could create that thing that magically seems to do this really complicated task, right? To sort of focus on understanding first. So that means maybe a bit more math than you might see, but it doesn't just mean theory. It means sort of when we talk about operating systems or networks or whatever it is, we want to really understand what's going on, right? A networks class at Reed is not a class about networks coding, though of course you do that. But it's a class about sort of really understanding how networks work. And I think that philosophy sort of carries over to everything we teach, right? We really want you to know what's going on and to ask questions about why it works that way and how could it work better, right? What are the limitations? What of those limitations are fundamental versus just kind of the best we've done so far, right? Those are the questions we want our students asking. We want you to be curious and to approach it like a scientist. So that's sort of the general approach we take. We then build a curriculum around that. A computer science major at Reed, there's 5 classes that everyone takes, starting with intro classes that are primarily how to code, right? But we don't think of that as just the be all and end all of computer science education. You have to learn how to code because that is the tool we use for doing all the other more interesting things that we get to in later courses. So even from the beginning, we're sort of talking to you about the principles of why code works the way it does and so forth. That set of 5 courses includes everything from low-level systems about how a computer physically works to abstract theory about what computation is. Then there's a set of math classes that everyone has to take that are setting you up for what you will need to do algorithms and machine learning and graphics and all this other stuff. And then there's a set of electives. You have to take 4 and you get to pick from a variety. We're a liberal arts college, we're a small department, so we don't have tons of electives every year, 5 or 6, something like that. And we vary those up each year. So it's rare that we offer the same elective 2 years in a row. And that lets us offer a broader set of electives for you to pick from during, you take electives mostly junior and senior year, some sophomore year. And so there's lots of stuff you can pick from. I've taught electives recently on cryptography and private data analysis. I teach a public policy and tech elective. We have deep learning. I guess I'll let Greg talk about his, but there's, I don't know, we've had operating systems and networks, graphics, parallelism, programming languages. Yeah, I don't know, Greg, do you want to talk about yours a little bit or anything else you want to add
Yeah,
about the curriculum?
yeah. I think so. The ones I teach regularly are programming languages and deep learning. Occasionally also compilers. I guess the other thing to mention about electives is there are occasionally kind of these like seminar kind of very advanced electives. So next year, for example, I'm teaching a sort of special elective on program verification, right, directly in my research area. And those are a bit less regular, but we do try to offer them in various topics every now and then, so you can kind of get really close to these advanced research topics through your electives sometimes. Um, yeah, and then I think the only other thing to add about the curriculum is we maybe just to temper this, we are teaching the fundamentals of computer science. We want you to understand everything. Um, but as Adam said, we do think of programming as a skill you need in order to do that. So you certainly do learn those things at Reed as well.
Yeah, I guess it's worth saying that sort of we have this different motivation, but it lands us in a very similar place to something with a more vocational motivation of sort of like, what do you need to be a software developer? Um, but I think the difference matters, even if you end up learning mostly the same things. I think it's a different sort of outlook, and it means we're not chasing the newest trendy thing in the same way. We're making sure you have the skills to pick up new things as you go because things change very quickly in computer science. And we want you to be ready for whatever happens next. Um, let's see. Another major thing about Reed and therefore about CS at Reed is our thesis. So we have a very serious senior thesis at Reed. Um, not every college has them, and many who do don't take them as seriously as we do. But a senior thesis at Reed is a full year, 2 credit thing. You work one-on-one with a faculty member at Reed weekly, doing something that really interacts with current research in computer science. Um, they they look wildly different. You can sort of focus on whatever area is sort of interest to you. Um, right, I'm advising one right now on sort of the mathematical assumptions at the basis of cryptography, right? Sort of you build all of cryptography on these ideas that certain computational problems are hard to solve. And if you're wrong about those assumptions, the whole thing falls apart. So most of modern cryptography that's actually used is built on a very small number of assumptions that people have picked. And there are some other options that are around, and I have a student who's looking at some of those. I had a student recently do a thesis on elections. And if you sort of have multi-candidate elections and you impose some sort of fairness constraints, right? You have some sort of regional requirement about who ends up in parliament or something like that, right? How can you impose these constraints on election systems? That doesn't maybe sound like computer science, but a lot of mechanism design and game theory actually happens within computer science, and this is an area of active research. So there's really stuff from all over the place, and while I tend to advise theses in cryptography or related areas of theory, I don't only do that, and we have students who thesis in all sorts of things, whether or not any of us specialize in them at the moment. Greg, maybe you have some other examples.
Yeah, I guess one example on things that we don't specialize in. I have a student right now who's doing a thesis in something called quantum complexity theory or quantum query complexity theory, which is an area that's totally outside of my research, but that's something this student is interested in and something that he's working on anyway. Um, but aside from that, I do have a number of theses that are sort of more directly in my area. I have a student who's working on looking at language models and trying to figure out why they work or like why they make the decisions that they make. I have a student who's a CS biology interdisciplinary major who's working on um, using some like new twists on machine learning ideas to kind of engineer better proteins, like make modifications to certain kinds of proteins so that they work better in lab settings. So you can do all kinds of work in your thesis.
Yeah, and that's maybe a good time to talk about interdisciplinary theses because that's another read unusual thing. Um, so uh, I think a lot of colleges have sort of double majors where you just do separately a major in each of two different things. And Reed has those. They're not super common because you have to do a separate thesis in each area. But what Reed mostly does instead is interdisciplinary theses. So this is for when you are interested in something that really is at the boundary of two different fields, right? Where when you want to do something that brings together computer science and biology or whatever it is, and you construct your own plan. It usually involves most of a major in each of those things, but not all of it. And you've got to really focus on the area where it comes together, right? Rather than sort of treating these as two separate things. And you do a thesis that brings these things together. We have a standing interdisciplinary major with math. That's a very popular program where people work on sort of computer science theory and computational mathematics and do all sorts of really interesting things there. But we also get proposals for interdisciplinary majors combining all sorts of things. So CS Bio is pretty common. But like just within the last week, I got two proposals from students. One who wanted to do an interdisciplinary CS art thesis, who's interested in, among other things, non-photorealistic rendering. So if you want to like use a GPU to make a picture, but instead of making it look realistic, you wanted to make it look like a sketch or something like that, right? How would you do that kind of thing? And I have someone, computer science and Greek, Latin, and ancient Mediterranean studies, is interested in using computational techniques for archaeology and doing sort of cool, interesting stuff there. So there's all sorts of stuff you can do in theses, and they really are sort of like an interesting capstone at the end of what you've done in college. I think that's most of what I wanted to say. There's a variety of other things that the department does. There's a colloquium each week where we have all sorts of visiting speakers. Students have a group that organizes social events for students and a student colloquium where they give talks for each other. There's a lot of summer research that happens. A lot of our students do summer research with one of the faculty on campus. But also a bunch go to other colleges and do other summer research programs there. Yeah, I guess the other thing I want to talk about was sort of outcomes, because I think Reed gets attention in some ways for having a large number of people who go on to graduate school. And it's worth saying that that is very real and very true. We are one of the top colleges for the fraction of students who go on to PhD programs. Some years it's been as high as like a third of our students go on to PhD programs, which is wildly above the norm at other places. But it's also worth saying that that's still, even in our high years where a third of students do it, most students don't, right? Most students go get jobs in tech like they would in any other computer science program. So we have good preparation for a PhD program and we set you up well for that. But I sometimes think this makes people think that that's the only thing the Reed education is for. And I want everyone to know that that's not the only way you can go with a Reed degree. Yeah, so I don't know. I think I'll stop there. Is there anything else, Greg or Will, you want to throw in?
No, I think looking at the time, it might be good to have some questions.
Yeah, I can start. I got a student who messaged me who was curious to know a little bit more about what might be different about studying, computer science at Reed versus maybe like, I don't know, a large public or a research institution, maybe if there's any thing any of you would like to share about that.
Yeah, so I can talk some, and I think the other two of you might have things to add. I guess the first thing to say is like, while there are differences, like the core fundamental experience is like you're learning the same fundamental material, right? You're going to learn the same computer science in either place. I think there are some liberal arts colleges who think of liberal arts computer science as some wildly different thing. We do not. We want you to have a good fundamental understanding of computer science. But there will be differences. For one, your classes will be much smaller. We think of a class of 40 as like an unusually big class that we do only for intro, whereas that would seem tiny at many large universities. Right, you will have a lot more interaction with the faculty than you would at those places. We do not have adjuncts, we do not have grad students teaching classes. Everything is taught by faculty. You go to faculty office hours, right? Like everything is interaction with faculty. And our faculty is all here because we like teaching, right? We all still do research. We care about that. We are experts in our field. But if we only wanted to be researchers, we would not have come to Reed. We are here because we care about teaching and like doing it. And that is a major part of our job. Yeah, so that's, I think, different. There are other differences, right? We're smaller. So, if you're really set on one very particular area of computer science, we might not have an elective in that this year, right? I think the sort of normal thing in computer science programs is there's this broad array of elective and you take a couple. We have more than enough for you to like have some choice about what you take and take a couple. But if your heart is really set on database systems, that might not be offered that year, right? So there will be some reduced selection there. Yeah, I mean, I think there are advantages to having sort of like more research happening, but I think there are also a lot of advantages to having people who are actually focused on students. And I guess the other thing related to that is that even when we do research, we are doing research with students in mind, right? One of the reasons we do research is that we can include students in that research and give them experience doing that kind of thing.
Yeah, I guess maybe the one thing I will add from my own experience, I went to a large public university, is maybe obvious, but you will take a lot more classes outside of computer science at Reed than you would at another school. Personally, I think that's a big positive. That's something that I think I would have benefited from quite a bit when I was an undergrad. But that is quite different. I mean, that's sort of shared for all liberal arts schools, but that's going to be quite different compared to a public university.
Well, maybe you have, I mean, I guess obviously you haven't been a student anywhere else, but
I mean, the main thing I resonated with was the comment about faculty. Like, I feel like I take, sorry, I take for granted a little bit the amount of like the quality of the relationships that I get to have with professors here. Because that is like really, really a great thing about being here. But yeah, I haven't been a student anywhere else. I don't know. Yeah.
I'm seeing a couple of questions in chat, so if nobody has anything else to add on that, I might look at a couple of these. Um, so there's a question about if you already have programming experience. We do have a placement test, and generally, most of the time, that would let you skip the first class if you have sort of equivalent prior experience. So I think that's pretty standard, similar to other schools. It's a placement test we give you over the summer, and then you'll get either placed out of that first class or not. I don't know, Adam, if there's anything else.
Yeah, I mean, I think another thing that's worth saying is that we've been teaching the intro class in a sort of more flexible, self-paced way recently. So, because we often have people who sort of know 75% of the intro class's material, but not enough to really skip. And so we've been teaching it in a way that lets you kind of breeze through the part you already know and focus on stuff that's new to you, and maybe take an extra class alongside it if you want. So it's not sort of an all or nothing, did you pass the placement test kind of thing. Yeah. Then I see a bunch of classes of sort of like, do we have classes in this particular thing kind of questions. So I guess let's go through those really quickly.
First is NLP, so I can.
Yeah, go for it.
We don't have, or at least I haven't haven't yet taught a class in NLP specifically. We do talk about NLP in the deep learning class that I teach, and that's a class that generally is offered every year because there's a lot of demand for it. So you can get some exposure to that, but at the moment there's not a sort of specific focus on that.
We have taught it in the past. It depends on sort of who's around and teaching what in different years. And you can thesis on it even if you don't take a class specifically on it.
Yeah, like I mentioned, one of my students is currently working on language models, and their focus is specifically on interpretability, but you could do a thesis on natural language processing, on a variety of different topics within natural language processing to get that kind of experience as well.
Yeah. And then I guess Grant, interrupt if you have other things you want us to answer, but I can keep going through this list. So there's a question about Linux system development. There's nothing specifically on that. We do some sort of software development, software engineering type things. We do operating systems, but they're sort of broad academic areas rather than sort of specific applications like that. But we do have people who work on that kind of stuff. I think C-Star, some of the students who are interested in that work together and do some stuff outside of class. And there's one about cybersecurity, and we do have lots of cybersecurity. It's actually sort of funny coincidence that out of 6 faculty, 2 of us are cryptographers, and we have quite a lot of cybersecurity going on in a variety of ways. So I teach a cryptography class, or me or Erica will teach it, depending on the year. That does sort of the more theoretical side. Cryptography sort of builds the toolbox you need to make cybersecurity happen. But then there's lots of sort of hands-on details about how you actually make cybersecurity happen. So Erica teaches a cybersecurity and computer systems course that does a good overview of cybersecurity. And I know she's advised a bunch of more applied cybersecurity theses too. So there's a whole range of stuff available there. Yeah. Then let's see, do I know of anyone doing a thesis in game design and development? So I don't know of any at the moment, but it's definitely happened. Generally, if you're interested in game design, we ask you to find what the sort of fundamental academic computer science is within what you want to do. So people have done a variety of different theses that aim towards games in a variety of ways. So for example, you might do a machine learning thesis where you work on an artificial intelligence player for a game using some interesting machine learning. Or you might focus on graphics, right? We have a graphics course that's taught pretty regularly, and a bunch of people have done graphics-focused theses related to games. But we do want a thesis to sort of use fundamental innovative tools from computer science, right? A thesis is not just a software development project. So a lot of them are software development projects, but using some sort of innovative new thing or with a goal in mind, right? We're going to implement this network protocol because it's interesting and we want to make measurements about it and see how it works, that kind of thing. There's going to be some sort of larger academic goal in mind.
Yeah, I'm not aware of. I've only been here for 2 years, so I haven't seen a lot of these theses come and go yet. I have always thought game development would be a really interesting topic for kind of an interdisciplinary thesis in CS and art or CS and English, something like that, because that's
the CS art interdisciplinary thesis I mentioned that someone's just applying for now has game development in mind.
Yeah, and to the second part of that question, the art, like digital media lab, I'm taking an art class this semester, and our class's focus is on video editing, but people come in to use that space for all sorts of things. So I don't know that there are students that already use it that way, but you absolutely could.
And then to the next question, the DRM posters you saw around were a student organized event. So maybe just to give a brief kind of discussion of that, there is a student organization for computer science, C-STAR, which maybe stands for something. I'm not actually sure.
Computer science students at Reed, I believe.
It's at Reed, okay. Yeah, so those posters were related to a hackathon they were putting on, and they are good about putting on events, regularly, including let's see. So they did the hackathon. I know they do like career panels sometimes. They did one of those recently. They'll do kind of trivia nights, all kinds of social events, both social events and kind of career slash just coding for fun events. They do a lot of those things.
So just a question about how, and maybe it's a good question for all three of you or whoever might want to tackle it, but how students maybe adapt to Reed's conference style learning in more STEM-based classes, or how that might look.
Yeah, so the format for classes is different in every class. There's a bunch of our classes that are pretty standard sort of professor in front of the room lecture classes. There are a number that are kind of a little bit of that, and a bunch of like students presenting and reading papers and doing kind of seminar stuff. My ethics and public policy class is really a sort of like discussion around a table thing in the way you would see in like a philosophy class or something like that. Our intro class is kind of flipped, and you watch videos at home and sort of do most of your work in lab, in class with people around to help. So the class format varies drastically. We don't think of there as being sort of like one correct format. We think you can make a class in all of these formats quite good, and you have to sort of do what you do well and what you think fits the particular subject matter of that class. But yeah, I think people, I don't know. I mean, I don't know that the class format is a huge adjustment for most people coming in. I think K-12 education these days has a bit more kind of discussion and project work and stuff than it used to have. And I don't know. I don't think it's a huge adjustment, but maybe, Will, you're probably the best one to actually have thoughts on this.
Yeah, you're definitely right. I get the sense from the classes I've taken, computer science and math classes tend to be more lecture based, or like you do a lecture, you learn the material, you do a homework, you turn it in. But there are certainly conference-based classes outside of the major, and taking those I really enjoy it. I think Reed definitely offers and encourages students to take a lot of those opportunities where you are taking these classes that not quite within your comfort zone of how you learn. Um, and I certainly appreciated how like I learned how to interact with people more through those classes. Um, so I think that it's not something that you're going to get in every computer science class. It's not a universal thing at Reed, but there is some of that you experience.
Yeah, it's worth saying your CS major, including all required classes, takes up about half the courses you would take at Reed. Um, so you have quite a substantial portion of your schedule that you can use for other things. And that can be computer science, math, and statistics, and so forth. That's beyond the requirements of the major. Um, Many of our students take more classes than are required. But even if you're doing that, you have room in your schedule to take other things. Um, and we very much would encourage you to do that and to get a broad education.
Yeah. So there's another question here about how often classes involve programming projects. It depends on the class. I'll say my classes pretty much always involve substantial amounts of programming. Um, and sort of as you're alluding to in the question, it's programming in service of understanding some theoretical goals. So for example, when I teach programming languages, my students implement a programming language. That's a really substantially sized project, and it sort of comes together over the course of the semester. Um, Same thing in deep learning, right? My students are learning about the fundamentals of statistical modeling and machine learning. They're also writing code to train actual machine learning models throughout the semester. So certainly many of the classes will have those kind of implementation projects. I've been working with another professor this semester to sort of put more implementation or more substantial projects into our not the very intro class, but like the second level intro class. So yeah, there are definitely opportunities to work on those kind of projects.
Yeah, from the beginning, there's projects and intro, right? I mean, when you're learning the basics of coding, there's going to be a lot of like small little bits of code you write, but there are also some much larger projects. And as you go up through the system, they get larger and they get less scaffolded, and you get a little bit more freedom to design the project in a bigger picture way. I think the only classes that don't have much coding in them are the true theory classes, the ones that are sort of cross-listed with math. But even there will be some. When I did private data analysis, which really is a theoretical class where you're writing proofs and stuff, I also had my students attack supposedly anonymized data sets and try to, break things.
And then in terms of what languages, we teach Python first in intro. The second CS2 class is sort of designed to get you closer to the details of how computers actually work. So it's actually taught in a mix of C and C++ and assembly to kind of give you a range of different levels of programming language. And then electives are taught using a variety of different languages, just depending on what makes sense for that elective. So I've mentioned programming languages. I've typically taught in OCaml or another kind of strong functional language of that kind. Deep learning is taught in Python because that's what everybody uses for deep learning. I do know that the students, like C Star, has a pretty strong community of practical programming projects, and they use, I think, a variety of different languages just down to individual preference.
Yeah, our goal is not that we have to teach you a very specific programming language at length. Our goal is that we teach you in the course of learning whatever particular programming languages are in intro. the stuff you need to pick up other programming languages as you need them.
Yeah, I can definitely say, as somebody who works in programming languages research, languages go in and out of fashion all the time. Um, so in some ways, it's a lot more important to be able to know the basics and pick up new languages than it is to kind of worry about the specific languages you're learning in a particular class.
I had a question that was shared with me. Students were curious to know just about when it might be a little more common for them to, like do research or internships, if they can maybe start doing that sooner, or if that maybe takes place a little bit later on in the pathway.
Yeah, so it depends. It can be a little hard to get. So, I mean, first of all, I should say most of this happens over the summers. I think that's the most common time to do research or internships, though there are exceptions. Um, and it can be a little tough to get something your first summer after your first year, but it's far from impossible. Um, Even if you don't know anything coming in, if you've taken 1 or 2 CS courses your first year, there are things you are qualified for over the summer. But most commonly, I think it really picks up after sophomore year. So you have sort of summer after sophomore year, summer after junior year. And in both of those summers, it's very common to do internships or research experience. Um, I think there's value in sort of doing one of each. I think they give you different experience and skills, and so, I mean, it depends what you want to do after college. But those are both very good. And yeah, I mean, it's pretty common. The internship application season is quite early these days, so we spend a lot of time kind of bugging students early in the year to remind them that now is the time to apply to internships. But yeah, it's quite common. And the research that happens on campus is almost entirely with Reed students. We don't sort of host a lot of REUs for students from everywhere. We are usually building research groups out of our students that we've seen in class that we've been impressed by and want to show them some other stuff they can do. Let's see, do we have other questions?
There's a new one in chat about previous new students coming in with projects. I'm not sure. Chance to show their experience. Could you just maybe clarify a little bit what you mean by show your experience?
Yeah, I mean, we're happy to see projects you've done before, but usually we do placement with placement tests rather than with projects. The only reason we would need to like really go in depth through stuff you've done before is if you are looking at placement out of more than just the first course. And then we might want to talk to you about additional stuff. But separate from placement, I mean, we're happy to see things. We're happy to know what you're interested in. We're happy to talk to you about sort of like what courses might be good to take, given those interests.
This is maybe a question for Grant.
No, thanks for the clarification. I would say similar. We're always very happy to see it on the admission side. It's not required, but if there's something that you would like to share to just kind of showcase your interest or to supplement your application, very happy to have it, but by no means required. You're applying to read, and we're excited for you to potentially join us, but you also don't have to apply to read in a department, so to speak, at the same time.
One thing we should say very clearly is that you can do a CS major at Reed even if you have never coded before. We do not expect anything coming in out of students other than standard high school level math. Right. If you are here ready to take intro CS, ready to take calculus, right, then like you are set and you can do everything from that point. We love people who have more experience. It is great, but I think sometimes people think that CS is something you have to sort of have done as a hobbyist for years before you get to college, and you don't. And often, if you have done it as a hobbyist, you have like a whole extra set of skills that are different from what you would learn in an academic computer science class. And that's great. And those things help each other. But it's not the same thing as what you're learning in your classes. Yeah, the placement tests are taken, you can take them when you get to campus. They're actually usually taken remotely over the summer before you get to campus so that we're not scrambling to do anything at the last minute when you get there. And they shouldn't be the sort of thing you have to panic and study for. As we said, like we're teaching intro mostly to teach programming principles rather than any one specific language or anything like that. You don't have to, like, our intro is in Python. You don't have to take the placement test in Python. You should not panic about the placement test. You will get information about it. It's not the sort of thing you should study extensively for. And yeah, as I said, we have sort of flexible setup so that you can sort of start in a kind of sliding way, even if, right, it's not like you have to be purely know nothing already or be through the first course. There are kind of in-betweens. And so it's flexible, and hopefully the placement test is therefore a bit lower stakes.
I think we have time for one more question that I'd love to pose to all three of you. What is it that you love about Reed?
Well, I guess I can start. Well, there's a variety of things I like. One thing I really like is being able to have a job that values teaching. It's something I care about. And it was clear that if I was going to a lot of places, you get sort of warned that like one thing that would be really bad for your career advancement is to spend too much of your time being too good at teaching. I want to be somewhere where good teaching is rewarded. And so I like being here for that reason. But the other thing is, I would really just say is like the students, like legitimately, they're strong and they're pretty responsible. But I think the thing that really stands out is that Reed students, by and large, really want to learn things. Right. They are not here to sort of game the system and find the easiest way to get their name on a diploma. They want to actually come away with understanding and knowledge and skills that they didn't have when they got to college. And everything you do as a professor is massively easier if your students are motivated in that way. And it's not perfect. It's not perfect anywhere, but I think it's much more true at Reed than it is most places.
Yeah, I guess my reasoning is very similar. I was looking for somewhere where I could spend more of my time teaching than I would if I was at a big research university. And then among places that value teaching, Reed definitely stood out to me as having students who are particularly engaged, who have things they're really kind of passionate about and are also just curious about, whatever they're learning about. I also really like Portland. That's sort of not about the college, but it's a nice place to be.
Yeah. I I would say I sort of love everything about Reed. I've been posed the question before, like, what do you not like? And it's sometimes hard for me to come up with a really concrete answer. Um, I mean, I have sort of a different appreciation of the students here than the faculty do. But like, along with that same like drive to do academics, people here are like so great. Like every single person is able to find a group that they and like fellow people who have the same interests and sensibilities, and like the same drive toward like anything that they are looking towards. And I'll echo from before, I also have really great appreciation for the faculty. That the wanting to learn and wanting to teach really go hand in hand super well. And there have been some times where I haven't been as inspired to just learn, and the professors care so much about teaching that it like pulls me out of that, and it really like engages me in, what's happening here. Also, the campus is beautiful. That's a great, yeah.
Thank you all for sharing your thoughts there. I want to offer a tremendous thank you to Adam, Greg, and Will for spending some time with us today, sharing more about the computer science program, but just more about Reed and the community here and what happens on campus. And we want to offer a thank you to you as well for spending some time with us and getting to know more about Reed and our values here. And there'll be more sessions to consider joining, opportunities for other office hours in addition to student panels, conversations with the college president. So keep an eye out for those. Hopefully we'll see you at a future event. And a tremendous thank you to everyone for your time today.